Hi, welcome back to our data analytics class. So, as I'm thinking about how to showcase, how to explore about data analytics in a practical way. So, as part of it, I asked AI that let's say we create some data set and we do something. So let's see what I've asked to AI. Like, I think generation of the data is the better, I mean, by own. So but like, as AI replied to us, like, yes, but with one important modification. I don't recommend generating random data. I recommended generating a realistic retail business data set with a proper business story. Based on everything we have discussed over the last few days, I think this is the best investment. Why generate our own data set? Because we can control every table, every relationship, every business rule, every data quality issue, every regression example, every clustered example, every Power BI dashboard, and every SQL query. So when a student asks why is this value missing, you'll know the answer because we designed it. The reason I'm planning of generating our own data set. Okay, here the data set I propose. I mean, AI is proposing database name retails analytics DB. For analytics DB, we have tables like this. We have in customers we have 1,000 records, and products we have 300 products records, and categories around 20, and suppliers 50, and employees are like 100 we have in our retail store. And stores we have like around in 25 stores we have 100 employees, and around we are considering for our stores like 5,000 orders, and order details we have like 15,000 to 20,000, and payments around 5,000. This is realistic without being unnecessarily large. So then we'll build so version 1 with clean, no issues. And in version 2 we will intentionally add 30 like quality issues, like 30 missing values, 20 duplicate records, 20 outliers, 20 invalid dates, 20 wrong totals, 20 invalid customer IDs, and invalid product IDs, blank strings, leading spaces, trailing spaces, mixed cases, and negative quantities. Everything will be documented. So then we use the same data set for everything. Like SQL Server, we'll use select group by clause, and we'll use joins, views, stored procedures, and data cleaning. And we can also implement Python by using Google Colab. We'll use pandas, NumPy, Matplotlib, and data cleaning, regression, k-means, time series. And we can also use data visualization tool for data visualization. Let's say executive dashboard, sales dashboard, customer dashboard, and product dashboard. Assignments, the students will solve using the same data sets. Many projects, students can also build projects using it. So time estimate, database design 2 to 3 hours, and all this, right? Okay, but meanwhile, I have a data set called orders underscore practical teaching. I have a orders data set actually. Orders practical. I have downloaded this orders data set from Kaggle. And one more thing I have, like, I have duplicated it into multiple sheets, original practical teaching and all. So right now, what I got thought, like, let's complete this with this data set, and later we'll generate our own data set, because for time constraint to complete quickly. So what it is saying, I asked this the same thing here. So this is the most important design decision for your entire course. Let's decide it correctly now instead of changing direction later. Your course is data analytics, not database management. Look at your syllabus. Unit 1 we have data management, unit 2 we have data analytics, and in unit 3 we are understanding about regression, and unit 4 segmentation, and unit 5 visualization. The end goal is analytics, not transaction processing. I mean, not data management. So what it is recommending a hybrid approach. Tonight we'll use orders practical teaching, and will create we'll create this table database, and we'll create the orders data sheet, and we'll import all 200 records. Then we'll intentionally introduce these missing values, duplicates, outliers, wrong totals, and inconsistent payment methods and invalid dates. We'll use all this intentionally using SQL update statements. Then this lets you start teaching immediately. So that's what, for a time constraint, to do it immediately. After phase 2, after unit 1, now you design the real project, not a single table, a complete retail analytics database. Now comes your actual question: should it be an OLTP, I mean transactional database, or an OLAP, I mean data warehouse? So the answer is, this is exactly how industry is working. First, we need to create an OLTP database, which is nothing but retail DB, and then we need to create the customers, products, suppliers, categories, orders, order details, payments, employees, stores. This is where transactions occurs. So example, customers buys a laptop, orders created, and payment recorded, and inventory updated, order shipped. This is OLTP. From retail DB we create retail data warehouse. This is data warehouse. Instead of transaction tables, we create here like dim customer, dimension product, dimension date, dimension store, and dimension employee, and fact sales. With all these tables we can create the schemas like star schema or snowflake schema in that scenario. So like fact table will be surrounded by, like rounded up by dimension tables. Like fact table is in the middle, and dimension customer, dimension product, dimension store, and dimension date, and dimension employee. These all are surrounded by fact sales. Now all analytics happens here. Why this is perfect? You can explain database, and then we are doing extract, transform, load, ETL transformations, and then we are transforming to the data warehouse. From there we are doing analytics, from analytics using Power BI or else any data visualization tool, and then we are doing the regression and clustering is nothing but grouping and visualization using the same business. Students finally will understand why a warehouse exists. Okay, my recommendation tonight: don't build retail DB, don't build retail database. Use the order sheet and finish SQL Server import and Python notebooks and data cleaning practicals. This gives you material you can use in class immediately. This weekend or after 1 minute, we'll start the real project, retail DB and all. Okay, now my plan is to complete immediate thing, which is nothing but to create the table and database and all. Right. So I don't want to continue on this data sheet. Instead, I'll take one more AI, same the chat GPT with new interaction, so that this interaction will start with next. Okay. So I completely agree with this plan for your specific teaching situation. I think it's the right sequence considering your syllabus and your available time, and the fact that you are teaching data analytics, not DBMS. This approach is practical and academically sound. So phase 1 orders practical DB database. Okay, fine. For this, let's create a database and table as per the sheet data we have. So I'm copying it. So now we are doing we are creating a database using SSMS. Let me open SQL Server Management Studio. I'm using SQL SSMS 2020 version. Okay, now I've opened SSMS now. As So now we will create the table. It's not working. That is fine. Fine. So let's do all this. So now creating a new query. Okay, in this we have we need to create a database called orders practical db, and also use this. So this master will go to orders practical db. Let's execute this. So we are into orders practical db. When we see under the database, we can find orders practical db also. This got created. Now then we create the table. Okay, we'll create the table. Let's take a new query. Let's create a table. So what we are creating table called varchar primary key. Why we are giving the primary key? Because here we don't have duplicates. The reason we are giving it as primary key. And dates, for every order date there will be no nulls. I mean, without date insertion, we don't have any orders, right? For every order we have dates, right? So the reason we are giving that will be a not null. Okay, not null. And without date there will we don't have any orders, compulsory, right? The reason we are not indicating as null, we are not allowing nulls. We are saying that column supposed to be not null, and same customer ID is also same, and everything is same. And in items in cart, it will be the count of items. The reason we are having it as int. So everything is fine. I'm just executing it to create the table. I've created the table as well. Now we need to insert all these data into the table, right? So this is our target. So far we have created the table, and right, this is the table, right? So far we have created this table. Now we need to insert the data. So you guys can see now insert sample inserts, but we'll insert the data exactly. So how to insert that? So what I'll say, instead I'll say that let's write a insert query at the last column, and will apply for all the rows. By having a formula and also explain the formula. Okay, I mean, what is the last column? Last column is till n. So till n we have values and column. At O will have insert query. Yes, this is actually one of the easiest way to import data when teaching SQL. Instead of using SQL Server import wizard, you can generate an insert statement in Excel for every row. So we have you guys can see we have A, B, C, D, E, F, G till N. We have all the columns. At O we are writing the SQL insert query. Formula for cell O2 is insert into orders. All these we have. So continuation for the data insertion of our orders data. So what I have asked to the AI, we have this Excel sheet, we have this orders data sheet, orders practical teaching sheet. So in this we have A to N columns, and we are supposed to insert all these 1200 columns into this table, into this orders table. So to do that we need to write insert query for all these 1200 columns, right? So instead of writing for all these 1200 columns, we have one option for like import wizard to import all Excel data. Okay, instead of doing that, like you can see import and export settings, so we can do from here, that as from Excel as well. But I don't want to do in that way. Instead, like in my real time practice, what I have did, I am doing the same. And I want to explain you all how I am doing, how we supposed to do. Okay, so what I have asked to AI, let's write a insert query at the last column, and we'll apply for all the rows by having a formula, and also explain the formula till, and we have values and columns. At O we have an insert query. That's what I have asked. Okay, so here we have our Excel sheet is arranged like this, right? A order ID, B order date, C customer ID, D product ID, and E quantity. In that way we have till n, and at n we have total price. At n we have total price. So at O I need a formula, right? At O I need a formula. So what is the formula? How to do it? So how the formula got created? So I would like to explain that the reason I asked the AI to create it. Okay, so any formula in Excel will start with equals. Okay, equals, and then we are writing with like all the columns, like insert into insert into orders as per syntax, insert into orders table, and then all the column names separated by comma, and then values, and here the actual formula is getting started, right? So how it is here, you guys can check. We have single quote and double quotes and ampersand and A2 and ampersand, and again closing with single quotes and double quotes and single quote. Again for date also same, like single quote and double. So here we have single quote and text for date. We are for to have a proper number, we are using text over here. Like AI will help us in understanding all this. Okay, so order for the output for the first row, how it is getting, we are after executing this formula we'll get like this. Let's see whether we are getting like this or not. Okay, so here I'm pasting the formula. So I got the exact output how it is saying, right? So you guys can see, I'll do till here, and from here we can do like data, no, view, show, no, not able to get where is the word wrap. Right, we got it, right? So you guys can see, we got the exact how it is saying, right? So in the similar way, we can drag this formula to all the rows like this, to all the rows like this. So so for that for that I have asked the AI to create this. Okay, so we are generating the formula, and we got like this, and how the formula works line by line explanation. So SQL starts the SQL statement, insert into orders. This creates the fixed part of the SQL command, and next insert the values from column A, order ID. So order ID, we are executing double quotes and ampersand A2 and ampersand and double quotes. So if A2 is order 2 lakhs, order 2 lakhs is the order ID. So Excel produces like single quotes and order, the value will come inside the quotes. So formats the date. We are using, even if Excel stores the date internally, this converts it into SQL friendly format like 2023 1 and 04, and text values like this, like text values we are doing like single quote, double quotes, and ampersand, and the column number like C2 and ampersand, again closing with single double quotes, and by end we are going closing with single quotes. This surrounds the value with single quotes because we need when we are writing the insert query for characters, we are closing with single quotes. For that, we single quote, double quotes, and ending up with single quotes. Whereas for numeric value, we don't need single quotes by end of this. So for that, we are writing double quotes and double quotes only. Okay, now you understood how we are writing the right. So until the last column, the same pattern is repeated for all the columns. So right. So now I don't want to waste much more time. So I'm doing it for all the 1200 columns, right? So right now, control N. Let's copy this like this. Let's copy, and we'll go to SQL Server, and we'll have a new query, and make sure you are in this the DB you are in. If not, it will show you error. And this is how this 1200 queries we can insert. So now I'm executing it. So all 1200 rows got affected. Let's see whether it got affected or not in a new query. Select star from orders. So we got all 1200 queries, all 1200 values, right? So we'll do intentionally twelve 1200 rows. Okay, we have inserted all the Excellent. Now you have excellent. You now have a working orders practical DB with 1200 records, which is a great foundation for your data analytics practicals. So current status: SQL server installed, database created, and tables created, 1200 records imported. Next, verify the data. We verified the data, and now count the records. Okay, we will count the records. So we are supposed to do all this. We are supposed to do all this. So count the records. So counting the records. And second, we need to count the records, right? So from this table we will execute, and the count is 1200. That is fine. Expected output 1200, we got the same. And check the table structure. To check the table structure, so we got the result as like this. Okay, and then we got result as like this. Instead we can paste it in Google Sheet so that it looks way far better. And this way we got, and this way we got it, right? And this way we got it. We'll give the same output to the AI. And we'll also give this output. Okay, now both are completed. Primary key information control are no identity. And then we'll give this information also. Okay, and then what it is asking, check for duplicate order IDs. Will not have any duplicate, but also will check for duplicate order IDs. I mean, if the output as 1, 2, then it might have. So we don't have any duplicate count. Control R. Okay, and then what it is saying, no rows returned. Check minimum and maximum dates. Check minimum and maximum dates. For that we have this query. So the first order and the last order is headers till 2025. The orders are starting with this and the last. Okay, and then total sales. We'll check the total sales. For total sales, this is the query. Total sales is this. And then distinct products, I mean what all products we have without duplicates. Seven. We have all these. And then distinct payment methods. Distinct means not duplicate. So all payment methods are debit card, online, and gift card. All these payment methods we have. Okay, all these payment methods we have. And distinct order status. Order status. So pending, return, all these are order statuses what we have under our right. Now we are ready for unit 1. So we'll intentionally make the data dirty to teach the data quality concepts. Okay, so for this we'll have all these till where I gave to the AI, till here I gave, but till from here to here I didn't give the output to the AI. So let's give, and we have completed till here. Then what it is saying, now we are ready for unit 1. The fun part begins. We'll intentionally make the data dirty to teach the data quality concepts. We'll create realistic issues such as missing values, duplicate records, invalid dates, incorrect total price, negative quantity, zero unit price, invalid payment methods, typographical errors, inconsistent product names, incorrect customer IDs, invalid tracking numbers, extra spaces, mixed letter cases, outliers, wrong addresses. These issues will be introduced using controlled update statements, so students can learn how to detect and clean them. Okay, that's what my agenda is all about. So the reason, excellent, this is exactly what we should do before introducing data quality problems. You have now established a clean clean database line. Current database health report. Database health report is total records we have 1200, primary key order ID, and duplicate order ID none, and data date range from 2023 year to 2026, and total size is like one, I think around it's I don't want to 13 lakhs, around 13 lakhs 82,819 is the total sales, and we have 7 unique products, and we have 5 status types. Okay, like order status. So one interesting finding, your query returned this: debit card, online, gift card, credit card, cash, credit card. Notice credit card appears twice. So since distinct should never return duplicate values, one of them almost certainly contains hidden spaces. Okay, for example, credit card SP, like space, we have space like this here. So, or credit card SP space like credit card like this. This is actually excellent because it is a real world data quality issues. Let's verify it. Select payment method, payment method as long length of text, and data length, payment length as bytes stored from orders. Let's try this. Okay, what it is saying. So to this, what I do, SQL 3 is a insert statement. So control S, not here, DA under 2026, here, what is archive, here we'll have new folder, SQL query files related to DA. Insert query for orders. Okay, now this is fine. Now here we have create table query. We can close this, and here, so how we created the database. Control X, can close this. No, don't want to save. Here I pasted this. Control S. Here article checking. Okay, now what it is saying, so at some point we have interesting fact is some it is shown credit card. So for example, we might have credit card and credit card space, all this. Like for that, let's verify it. So to verify, we'll have a new query and we'll paste it. And so length, to know the length of the payment method and length of the text, so we'll execute. You guys can see the answer with headers. This is perfect for unit 1. Your dataset is already showing one genuine data quality issues before we have introduced any artificial ones. You can explain, although both values look identical on the screen, SQL Server treats them as different because one contains an extra space. I recommended one more verification query. Run this once to understand your dataset is better. Okay. We can also do this as well. Till here. Control T, Control C, and Control R, and then we'll do to check the answer in this way. After that, We'll intentionally introduce data quality issues in a controlled manner instead of modifying random errors. We'll introduce issues category by category. Module 1 missing values, Module 2 duplicates, Module 3 inconsistency, Module 4 outliers, Module 5 incorrect values, Module 6 typographical errors, typographical errors, and Module 7 invalid formats. And my suggestion, don't introduce all the errors at once. We'll build the dataset step by step with each category corresponding to one concept in your syllabus. By the end of the unit 1, your students will have worked with a realistic dataset containing all the common data quality problems they are likely to encounter in industry. They'll also give us a reusable practical dataset for future semesters. So let's give this. So excellent. This confirms your dataset is already behaving like a real world dataset. These are the exactly kinds of observations that make for good classroom demonstrations. Payment method issues: debit card length 10 bytes 10, online 6699, credit card 1111, credit cash 44, credit card we have 12 and 13. So this tells us one value has a leading space. It also has a training space. SQL treats it's a different value. So to make it even clearer for the students, run this. Okay. So you guys can see here we have a space, right? Where for other credit card we don't have a space. So expected output we got like this, right? So student can immediately see the hidden spaces. Customer IDs total 1200, distinct customers are 1189. This is actually good. It means customers placed multiple orders. For example, customer C12345, order 1, order 2, order 3. This is a realistic e-commerce behavior. You can even show which customers ordered multiple times. Okay, multiple times. You even can show which customers ordered multiple times. And in products we got perfect. Students can easily perform grouping and aggregation. Order status, 5 statuses also perfect. You can later demonstrate uh, group by order statuses. And now your data set is now a great teaching data set. You already have repeated customers and all. So before introducing artificial errors, let's profile the data. This is exactly what a data analyst does before planning a data set. I recommended uh, creating a script named 01 profiling data profiling.sql. Include queries like this. Okay, this helps students to understand what the data looks like before training it. Okay, fine. Before that, I would like to give this answer to the AI. Till here, right? Control C. Now we'll paste it here. Then so we'll have control N, new query. This name supposed to be like this: data profiling. Control S. Fine. Now we'll give this. Excellent. Your data set is now validated when we have learned some important things about it before making any modifications. Data profiling report clean data set, metering total records 1200, distinct customers are 1189, and 11 customers have placed more than one. 1189 customers, I mean in 1189, 11 customers have placed more than one order. Distinct products 7, good product variety, and distinct payment methods are 6. One value contains extra spaces, and whereas distinct order statuses are 5. Realistic order life cycle and date range from 2023 to 2025, and total sales is like 13 lakhs. And observations, hidden spaces. Now this is an excellent example for data inconsistency. Why does SQL Server treat them differently? Although they look almost the same, they are stored differently. So value 1, credit card length 11, value 2, credit card length 12. The second value contains a reading space, making it a different string. This is one of the most common data quality issues encountered in practice. So observation 2, repeated customers 12, total 100 orders are 1289, distinct customers are 1189, difference 1200 minus 1189, and so 11 customers have placed 2 orders each. For example, C1487 order 1 order 2, this is not a data quality issue. It represents a value one to many relationships, one customer many orders. This is normal in an e-commerce system. This is a good teaching opportunity. You can ask students, is this a duplicate? Most beginners will answer yes. Then explain, no, the customer ID is repeated because the same customer placed multiple orders. The order ID is different for each other. That helps students understand the difference between duplicate records and valid repeated values. So another useful verification query is show whether any order ID repeated. Okay, order ID repeated. I think no. No, right? We have successfully completed phase 1 data profiling, tables created, rows 200 rows imported, and then now next phase we are now ready to start data quality issues. I suggest we introduce them one by one category at a time, so each practical session focuses on a single concept. 1, missing values, duplicate records, inconsistent text values, outliers, invalid values, incorrect formats, data validation. So this progression matches how data analysts typically approach real world datasets, and will make each classroom exercise focused and easy for understand students to follow. Okay.